All right. So, firstly, I wanted to I wanted to know from you the whole story from like about you. So how you got into the field, how you learned all the things that you know, the understanding you got about the machine learning, the computer science, the mathematics, the physics, the quantum physics, the deep learning, and knowing all those things together is really complex task. So yeah, tell me how you did all
For
that.
sure, yeah, no, it's all complex putting these things together, right? So to me, when
Right.
it comes to machine learning, it's all about putting disparate pieces together and all of these disparate things together, and that's kind of what I've done my whole entire life. I started off
Right.
uh, taking computers together and putting them apart as a kid, a
Right.
lot of that, and then just understanding how they worked. My very first job was in IT. My very first like main job was for Apple computers, like a
Oh,
long, long time ago.
that is awesome,
And
man.
then,
You work for Apple. That is
yeah,
really, I admire that, man. Yeah, awesome.
thank you.
Yeah.
Yeah, and so like it's I spent I had a lot of actual exposure to that early industry. So
Mm-hmm.
Apple computers was my first job. A lot of my second job for a long time was for Intel, and then I
Intel.
worked for Intel like yeah during
That is
kind of that
awesome.
period where it's you had to me it was interesting, right? Because you had the introduction of the Pentium fives, and then it's all of
Right.
a sudden you went to dual core, and then from
Right.
there. So I
Yeah.
was
So you
essentially
you were in the team with the people who developed the Pentium and all those things. So yeah, I learned Pentium as my introductory course as my computer science class back in my 2020 or something like that. So yeah, it is really honor to meet someone who designed a processor. So yeah, it is really awesome. So awesome, man.
for sure.
Yeah.
Yeah, for sure. Yeah, and then so from there, it's more recently like I went to data science, a lot of data science roles. So about like 3 or 4 years with an org where I kind of just was able to. I got the luxury of running their entire systems, and then they wanted to be a very data driven org. This was like during that time when it's. That big transition towards data, and then so they just gave me full reign, and so it's a very great opportunity for me just to learn everything from the ground up, and that's kind of my first exposure to these things, like getting deeper into like deep learning and understanding kind of more behind machine learning, kind of utilizing exploratory algorithms, and then going from there. And then previously, again, to me, it's all disparate fields that it comes together. So my kind of love for physics started in seventh grade. I learned
Okay.
of Swedish cat and that whole concept, and I couldn't make sense of it. And then so I spent a long time up until I was kind of an adult, trying to understand. I wanted to understand what exactly is this concept of quantum mechanics and quantum physics, and it's always
Right.
just fascinated me, been in the back of my mind, and it's been disparate to computer science to me, but I've always just carried forth that as a passion, as a hobby. Same thing with regards towards mathematics. In high school, I actually, in high school, I failed algebra my very first time. Like and
Okay.
aced geometry. It's kind of like how my
Right.
brain works.
Okay.
And then I just like,
So you
same
visualize
thing in
things better than normal
exactly,
humans.
yeah, very visual. Like
Right.
same thing in college. You know, like I
Right.
aced logic, and then
Mm-hmm.
I struggled with statistics. And it's
Statistics.
just
Right.
like I'm very visual, and then
Visual.
so it's
Right.
yeah, and then that's kind of just how I built my foundation for mathematics as well. Like big on Nash theory. So like once I discovered Nash theory and John Nash and game theory and all of that, I kind of fell in love with that overall. like I
Game
like
theory is
like
really awesome. So what's your take on the game theory?
yeah, for sure. Like so, my take overall is it's to me how probability works. I think that there's a probability lever overall,
Right.
and then no matter what the situation is, regardless, you can essentially move this probability lever. Let's say 3 to 4% is kind of how
Right.
I look at it. And is what game theory gets you, and it's
Right.
regardless of any situation. And then like in any situation, being able to move it 3 to 4%, that's pretty good, right?
Right. Yeah.
Uh,
Completely.
it,
Yeah.
it, and it plays out, casinos like moving it 3 to 4%, that gives you the advantage, and it's
Right.
just it's a cool concept overall. I like it.
Right. Awesome. Awesome. So yeah, we'll continue the story. All right.
Awesome. Yeah, so like just keeping on with kind of that track and that trajectory. So more recently, I got heavily into consulting for about the last 10 years or so, and then within that, it's just been keeping in the forefront of um, technology, and then more recently, just diving deeper and deeper into machine learning, deep learning, and all of the aspects of that. Kind of just diving heavily into the research behind it. You have open AI comes out, things like that. I start getting deeper into it at that point. Very first thing, my background is again like engineering, right? So
Right.
when I see like ChatGPT first come out, I reverse engineered it. Like I just go through
Okay.
it,
So
took it
what you
apart,
did
and then
when you like reverse engineering the whole thing, because ChatGPT was
exactly
like a closed source, right? So only
yeah,
APIs were
exactly.
open. So yeah.
Yeah, exactly. Like I wanted to understand, like this is how transformers work. Like this is an
Right.
individual transformer, and then I broke it down into this is matrix arrays. Like
Right.
understanding the mathematics behind it, how exactly that works, what exactly is going on with matrices, the attention mechanism, the
Right.
tokenizer. I kind of just like took it apart piece by piece,
Right.
and then I was like,
So
how does
attention
this work?
mechanism is the thing that like a lot of people don't understand properly. So I'd like you to like go something, talk something about that as well. After you finish your explanation. Sorry to interrupt.
No, absolutely. No, I,
Yeah.
I mean, to me, that like, there's over the two most fascinating parts of the model when you start, taking it apart are the attention mechanism and
Right.
the tokenizer. And then to me, the
Right.
attention mechanism is interesting, right? It's
Right.
um, all the attention mechanism does overall is it as mathematically, it's essentially mathematically the model should pay attention to this to x, and then whatever like that is within the equation is how the attention mechanism works within the
Right.
standard attention mechanism. What happens is like mathematically, the more information that you introduce to that,
Mm-hmm.
it has to go through, right? So you're saying like, here's a grid, and then on the grid I want you to only pay attention to this certain point, which is
Right.
easy, right? That's easy to do. So then it
Mm-hmm.
goes through and it focuses its attention there. But
Okay.
if you make that grid bigger and bigger and bigger, then it has to go through more and more search space, and then that's where essentially you could run into problems with the attention mechanism
Right.
as you increase the search space. So kind of
Right.
a lot of the efficiencies are, um, do we have to search through the whole search space? Can we do it in a non-linear fashion? Do I have to do it through this? Like, could I just maybe go here, 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 here? And then so that's where you get into kind of the unique aspects of the attention mechanism overall. But the attention mechanism in and of itself is very simplistic. It's just pay attention to X. And then there's not a lot of variability of what X is. X can be the next token, it could be the next sentence, it could be a paragraph. It's just pay attention to a certain part of the data set.
Right. So, what I understood from the attention mechanism is like if there is a sentence like this is a cat, then it will make sense from the if the cat is the thing that we are focusing on, and it will make sense this like the two words before that from the cat, and it will make changes into the matrices which are in the transformer. So I just know those things, but I don't know how that happens. So can you let me know how that works?
Yeah, absolutely. And then so that's exactly it. Like that goes into that framework of what you want it to pay attention to, right? And then so in common instances, like the most common attention mechanism is exactly what you
Right,
just laid out. So pay
right.
attention to the token before and the token after,
Token after.
and then predict based off of that. And then what
Right.
happens? Like the problem with that is that's wonderful if you have like a limited solution space, but
Exactly.
what yeah, what happens is with a typical attention mechanism, it's connected to every single parameter within the model, right? So
Right.
it's not just doing that one time every
Right.
single time. It's doing it if it's a billion parameters, it's doing it a billion times each time.
Exactly. So
Uh,
it will be like crazy. Yeah.
exactly, yeah. So it scales, the math scales exponentially is like the problem with the standard attention mechanism.
Right. So how you visualize the whole dimensions in the vector space? So please give your take on that. So when we visualize all the tokens, because I heard there are like 13,000 dimensions in the ChatGPT tree. So how we can visualize that. I cannot like even fathom how to think about that. So yeah.
For sure, yeah. Dimensions to me is interesting, right?
Mm-hmm.
Uh, I like to me dimensions. How I kind of visualize dimensions are just it's another shape essentially. Like it's you are able like I look at a dimension like a box, and then you can stack boxes on top of each other, but you can also stack
Okay.
them sideways. You can
Okay.
stack dimensions into different angles, but it's based off of hierarchies. Is like the main point of it, right? You're always stacking on top of each other, like,
Right.
but you can stack and fold. Like there's if you look at there's a really cool Euclidean diagram that I've made that's essentially how I envision it. Right, you have a box and then it unfolds like this, and that's how I envision dimensions. Like they can stack into each other.
So in any way that it can go. So can we imagine that as a like tesseract, which was shown in the Interstellar last
A
series?
tesseract is a perfect example of that. Exactly. I think
Okay.
tesseracts and dimensions are very related to me. There's like
Right.
more and more of a connection between geometry and dimensionality. I think that the missing piece of physics lies in that very specifically.
Right.
Um, if you look at what the models are doing, that's kind of the open question that is still within the scientific community. Like, how exactly are the models?
Exactly.
What
Right.
exactly are they doing? To me,
Yeah.
they're reshaping the data. It's all geometry. I don't think that they're
Is it?
you
Okay.
give you like I think if you give them like let's say a text, right? Like
Right.
Harry Potter, like the
Mm-hmm.
book. I don't think that they learn the text of the book. I think that they take it and they essentially they learn the shape of
The shape
Harry
of
Potter.
the right, and the shape is
Exactly.
in the like so much higher dimensions that our mind cannot fathom it properly.
Exactly.
So
Yeah. Yeah. They're just
right,
so many dimensions. Exactly.
right. So the difference between every model is the shape of the model in the higher dimensional space. That's all the difference is, right? And that's
That's
all they are
I think
trending about. And yeah, that's all the mathematical things that are different. Like only the numbers which are stored in the different spaces in the math, like the vector spaces, and which are in the really high
exactly.
dimensional. Right.
Exactly. I keep refining this, but where my refinement is at the moment is I truly so I think that what compute is, so what the models do, et cetera, is they're going through noise. So in any data set, when you first are approached with the data set, it's just noise. You don't know
Right.
anything about it, how it works, anything like that. And then so
Right.
you apply compute or kind of brute force to the data set by reshaping it, changing it, stretching it, kind
Right.
of like making it, compacting it, and then doing all of these things to understand more how it works. And then by doing these things, these transformations to the data, you can get signal data out of it. So you pull the signal data out of the noise, pull meaning out of the noise, some sort of pattern.
Okay.
So you I like Harry Potter. I don't understand
Harry
anything
Potter.
about this, and I'm by changing the shape, all of a sudden the magic pops out.
Right.
Muggles pop out.
Right.
Like
Right. So something
Hogwarts
that
pops
is
out.
right. 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 Something that
Yeah,
is making sense. These things are popping out from like visually seeming like nothing, like nowhere. But yeah, it is something in the
exactly.
mathematical space. So that is really magical.
Yeah. They just pop out of this mathematical space. Exactly. Like,
Yeah.
exactly. It's all like to
Mathematics
me,
and physics
it's
are
all just
super cool.
mathematical spaces.
Yeah,
Yeah.
this is super cool. So you mentioned in some of your video that the mathematical space, the and the something about in the LCM video, I believe that you mentioned the computations are so much higher that the whole entropy of the universe will not be enough or something like that. I cannot recall the whole thing, but yeah, you
Yeah,
know.
like so, like the interesting thing to me about the LCM architecture, very specifically, like it's very unique architecture, right? Like so,
Right.
I saw a article about I think it was yesterday or the day before, where
Right.
physicists have now taken it a step further. I don't think they would have been able to do it without LCMs, but they've
Right.
essentially put it on chip now. So they've
Ah.
created a chip
Okay.
that has a hidden dimension on the chip,
Yeah, I
and
heard
it's
about that. Like the
basically
Google's Willow chip, yeah, the quantum
yeah,
computer chip, yeah. They have the
yeah.
104 qubits, and yeah, I never understood how that worked. So, what's your take on that?
It's I mean it's mind-boggling how it works, but it's very simplistic into how it works, right? It's
Mm-hmm.
so the bottom line is that within physics, observation in and of itself changes the outcome, or it decides an outcome, and that's
Right.
proven all throughout physics.
Completely.
If you observe something or you don't observe something, there's
Right.
two different outcomes.
Right.
And all throughout, like there's numerous different ways to prove that out. And then so just taking that framework, and then it's like within neural networks overall, you have a hidden layer overall, period, right? Like you always
Right.
have this hidden layer where you don't know what's going on within the hidden
Completely.
layer.
Right.
Uh, and then so, but you just take it to the next level rather than a layer. It's a hidden dimension. Like you create it as a dimension. Here's the definitions of the dimension. I define the dimension, and
Right.
then no one is ever going to look at it. Like we don't know.
Right.
That dimension is just a black box. Like
Completely.
the cat is both alive and dead in that box. We don't know.
Right. So I was having these like ideas. So if we like quantum computing is the field that like developing algorithms for quantum computing is really like a gruesome hard process. So I was thinking if we combine these like LCM things like LCM which can make sense of the concepts and make sense of the like ideas in the certain ways abstracts and we fuse them with the quantum chips in some way. I have no idea if that is possible, so that's my question. So is that something that we can do or something that can happen possibly in future?
So, like, I mean, this gets into this question here gets into like where we're at right now with physics. I'll answer it from
Right.
my perspective. Like, so
Right.
from my perspective, where we're at with physics, like more and more, it's proving out that it's a continuum is my hypothesis on this overall, right? So like I look at it, I'll break it down first into the concept of mathematics, and then so
Okay.
within mathematics you have linear algebra and geometry and calculus, so like
Right.
probabilistic math, right? And then so like linear math and probabilistic math, and then generally speaking people always like one or the other. I'm more on the
Right.
probabilistic side, right?
Right.
But I think that it's a continuum. They're both the same. And then so what like we're seeing more and more as because of these of AI and these models that are coming out is
Right.
we have new math that's being invented like as we speak, which is
Right.
like linear geometry, the bridge between the two, like the bridge between linearity and probability. Um,
Probability.
and then so in physics, I think overall we're going to end up in that same realm that classical physics and quantum physics, it's more of a continuum, a line. I don't think that there's a separation between the two, like a distinction
Okay.
between the two.
Cause yeah, I used to think like before this, the classical physics, the laws of classical physics will be like completely different than the laws of quantum physics. And yeah, the concept that you told me right now that like blew my mind right now. So yeah, that is awesome. So so yeah, that is awesome. So I was like wondering about the whole Apple thing, which like you worked in the Apple. So what you worked when you're working in Apple?
Yeah, good question. So like this is this is before even the .com bust, right? So
Yeah.
Apple is a very small company at that point, and
Right.
then so I was working tech support, and then
Mm-hmm.
so dealing very specifically with like I was at that point I was dealing a lot with like hardware issues with
Right.
MacBook Pros and
Right.
the big towers.
Okay.
And then I did. I was certified. I had my certifications both for desktop repair as well as laptop repair. So I took them
Right.
apart, put them together. Like I could at that time like take apart a whole computer and put it back together like
That things
MacBook
are super
Pro.
awesome, man. Like
Yeah, yeah,
dismantling
yeah.
the whole thing, watching every component, understanding the whole thing, and yeah, that is the beauty behind the computers.
Yeah,
That
exactly.
that's
Yeah, yeah,
really
yeah. And
nice.
that was fun to me. Like that's like that was
Yeah.
like those were like some of the funnest times, right? Because it's like all right, like
Yeah.
you would know your day. Like I go in and it's like all right, I'm gonna take apart two computers and put them back together, and that's my day.
Exactly.
That's what you do.
I used to do that like when I was kid as well, and yeah, once upon a time, like I wanted to empty my like make my disk space more, and I was like curious what is in the C folder, so I deleted all the program files, and I never knew what is happening. So yeah, that was really funny thing happened to me, and after that I got to know, yeah, these are program files. I'm not supposed to touch them. So yeah.
Exactly. But I mean,
Right.
like to me, that's the best way to learn is like that. Like I've always learned that way, like learning through like making mistakes, like and real
Right.
world, and like yeah, I'm huge on that. I dig it.
Yeah, that is really awesome way to learn, man. Like I saw like whenever you're diving into any research paper, you'll be having the piece of code that you wrote yourself, and you're going to like do some improvements in that, and that is really something that I admire of like the work of you. Like that is really nice thing, cause not a
For
lot of
sure.
people do that, and yeah, that is really awesome. So how you come up with the like modifications that you come up with for a lot of research papers? Cause even
Yeah, not
understanding the
like
research papers is really hard part for like lot of
I,
papers which are going on right now.
exactly. And that's exactly how I look at it, right? So to me, I
Right,
approach it like I've been an engineer since I was a kid. Is like I'm
right,
taking apart computers, putting them back together, and then
completely, yeah,
so I look at like research papers and all of that the same way. So I'll take the research
right,
paper,
mm-hmm.
and I want to take it apart, and then I want to reverse engineer it back, right? And that's my like that's how I understand it. If I can take it apart, understand all the individual pieces, and then I can put
Right,
the individual pieces back better, then
right,
that's my understanding. And then so that's like
completely,
why I do that a lot, right? That's my goal is
completely,
to, if I actually understand it, I can
right,
explain it to someone, and I can put it back together, and I can say, here's the flaws in it, here's how I can make it better, and here's how I
right.
can improve it.
Completely, that's what the art people do as well. Like they try to like draw the like they try to recreate the drawings which were drawn by the people like hundreds of years back, and they learned the uh, logic or whatever that thing from those paintings, and yeah, they get to like develop their own kind of thinking, and they can create their own paintings. That's how it works maybe in the research. So if
Exactly.
someone wants to get into the deep learning or AI research, so what's the path for that?
Yeah, no, that's a good question. Like I like to me it's there's so many disparate paths, right? So it's hard to say like here's the path that is the one path, the true path. But
Mm-hmm.
I think that the very first place that everyone should start is with the coding, right? With Python, because it's
Right,
that opens up everything else from there. Like whatever
right,
questions that you want to ask, if you want to dive into it philosophically, mathematically, from the
right.
physics aspect, you
Completely,
need to know how to code in order to get what you need to do.
completely.
And then so that's like the very first place to start. If you can do that, it's like a language, right? Then you can
Right.
go to anywhere else that you want to go from there.
Right. So imagine like someone who doesn't know anything from the computers, from physics, from mathematics, or even computer science, and they're like super interested in these things right now, and they want to learn, they want to get started. So what's the process for them? Can they
For
just
sure.
start
That
now?
okay. Like a complete blank slate, the very first
Yeah.
place that I would start would be the mathematics. It all
Right.
boils down to the mathematics and then
Right.
understanding matrix arrays. Like
Okay.
and so matrix arrays are very straightforward, right? And so it's the very first thing you concept you need to understand is linear algebra. You need to
Completely.
understand linear algebra, how that works, and then you need to understand probability because
Right.
the all models, no matter what the model is, it's always a mixture of linear algebra and probabilistic math. And then
Completely.
you get to play with how much of each of those. But
Right.
in order to play with those, you need to have that, you need to understand how both levers work. So
Completely.
that's the best place
Completely.
to start. Like,
Right. So people should have the understanding of math, and how much understanding, how much depth they should go in. Like the linear algebra, how much they should learn.
yeah, like, so to me, like, I look at math different than other people, right? So to me, like
Right.
math is flat out a subset of philosophy. And then
Right.
so
Exactly. And
to
that's
me,
really
it's
nice
more
way to look
important.
at it. Exactly.
Yeah, for sure. So I
Yeah.
like it's far more important to understand the theory of linear algebra than to like. I don't think you need to it's important like if you understand like Hamming distance, for example, and how a Hamming ball works. Like you want to know those things, but like
Right.
I think it's less like you don't need to understand like the Hamming distance equation. Like, but you need
Right.
to like you know to understand like why exactly Hamming balls
Completely.
are come up a lot, like
Right.
and the
You
theory
should
behind
be
it.
able to visualize how things are working. That's what I feel is important in maths. And when you
Exactly.
like
That's
develop
yeah.
the understanding and visualization on the whole thing, then maybe like the whole thing will be easy for you. So
That's exactly
maybe
it. That's exactly how I look at it, right? Like
right,
math is just a blueprint of how things work, and then so you
right,
need to be able to read the blueprints. Like,
completely, yeah. And the quantum mechanics is other big thing. So how you like how you will guide to like people who want to start from beginning.
Yeah, for sure. I mean, so to me, like I started flat out and I think it's a good introduction. Schrodinger's cat, right? They start off
Right.
there, and it's a good introduction. So understanding like Schrodinger's experiments, like here's Schrodinger's cat, as well as here's the wavelength experiments, right? The light experiments, and that's something that you can do at home. Like you take a piece of
Right.
construction paper, shine a light through it, understand
Right.
how that works, and then like
Right.
why is that happening? Like understand, like wave particle duality is hard, but
Completely.
understand Schrodinger's box, and
Right.
like both of these concepts are hard. But once you
Right.
can understand how that works in and of itself, then I think you take a step back and then you understand relativistic physics and then go into Einstein. So like,
Completely.
but I
Right.
think it's a good path. Start with Schrodinger and then go to Einstein.
Got to understand. Right. Yeah. Yeah. So, what's your take on the source equation?
On what?
On the source equation, the source algorithm or equation, the
Oh,
quantum
Shor's algorithm.
intrinsix.
Yeah, yeah,
Source
yeah,
algorithm. Yeah.
yeah, yeah. So I like. I think that there is an out I actually I go back and forth on this, right? So I
Mm-hmm.
debate this. Like, there's I'm on currently on a research team where we research these things, and then this this question we debate it back and forth.
Right.
Mathematically speaking,
Mm-hmm.
there is an algorithm that exists that you could solve anything with, right? That's the
Okay.
perfect algorithm.
Okay.
But uh, if you step outside of mathematics within that, then that would also be uh, whatever you're trying to solve for, right? So like
Right.
mathematically, if we take a data set, mathematically speaking, there's an algorithm that can solve for that data set. And then if it's Shor's algorithm, and then we could utilize it in that instance. But in that instance as well, there's also an algorithm, like the probability or possibility that it's actually the data set is much higher to me in that
Right.
instance than it's I think you are starting to get into weird math.
Right.
Unless or were you also all right with Schwar's algorithm? Were you diving into like the security
Mm-hmm.
ramifications of it around that as well? Like uh, with that, like with the security. So I think that that's a problem that there's no solution for right now, right? Like it
Exactly. Yeah.
is
The
it's a
error
real
correction
problem.
and the whole things which are going on, which people are still working on right now, like the quantum error correction on all those things. So, what's your take on the quantum error correction?
Yeah, I don't like. It's. I mean, I go back and forth on it, right? So I don't like.
Right.
Uh, so recently today, today and yesterday, there was two very recent advancements, or three, I guess.
Right.
One is that they were able to stabilize quantum entanglement across 54 qubits, which is a huge amount comparatively. Like they were like I think it was
Right.
previous was like five.
That is awesome.
So 5 to 54, that's big improvement.
Okay.
Second is that they were able to I have to watch the video, but according
Right.
to physicists, there's a chance that they've been able to solve low energy fusion, and then so like maybe so
That is
I need to
awesome.
check that out.
Okay.
Yeah, but there's been a few advancements recently uh, you look at it's interesting to me, right? Like I like to take away the hype, and then I
Right.
look at it like economically, commercially, et cetera, as well, right?
Completely.
So
Yeah.
quantum has been in the news like economically this week, and then it was Meta and Nvidia. They both they poo-pooed quantum a little bit, and then it tanked the stocks. It's like, and then you saw a whole bunch of
Right.
articles. They're
Stock
like,
market is going
these,
crazy right now. Yeah.
yeah, the stocks tanked by 26%, but then two
Right.
days later they're up 40%. And then so
Right.
it's like, okay, so like I mean, the money is actually backing quantum.
Right.
Get past the hype cycle. There's people that believe in it.
Right.
And we're getting more and more there. I think it'll be a switch, right? Like just
Mm-hmm.
someone's going to hit it. Like it'll be like a ChatGPT moment when it
Right. It
happens.
will be sometime. Yeah. Sometime later. It will be just like the sigmoid curve where the starting is the like slow movement, but after that things are going to get just like a lot of things are there, and no one knows what's happening. That will be
Exactly.
just like the dot
that,
com
that,
bubble, right?
that's exactly how I look at it. Yeah, yeah. Like
Yeah.
it'll be like once we crack that equation, it opens
Right.
up like a literal whole new multiverse, right? Like,
Exactly. Not universe, multiverse, and
Yeah,
Imagining
exactly.
that is like crazy.
Yeah, exactly. Yeah, just even imagining it's crazy.
Yeah,
Yeah.
yeah. Like gathering the whole in like power from a lot of universes just to compute something, that is crazy as well. I have no idea like if that is like correct uh, explanation of that thing, because I read some articles that are saying that some scientists are believing that and some scientists are believing something else, so I have no idea what is true, so yeah.
Yeah, but it's I don't know what's true with those either of those questions to either, but it's interesting times to me, right? I like because it's
Right.
like 95% of my life
Mm-hmm.
we would ask these questions. It's like, well, we'll never know. You know, it's
Exactly,
just I
right.
don't know, they're far away. But now it's like
Completely.
maybe we can know. Like I don't know the answer, but maybe we can find out.
Right. So, what do you think about the Turing test? So, do you think that we passed the Turing test with the large language models that we have right now, or not?
Yeah, that's an interesting question. I think that like so when it comes to like like where we are with the intelligence of AI, I think that there's a lot of moving of goalposts. I think that I mean if you look at exactly what the Turing test is, pure definitionally, we've
Right.
passed it. Like we've passed that line. Like there's like
We passed the line.
multiple examples and tests of uh, here's like ChatGPT passing that line, right? But
Right.
I think that you can also show earlier instances. Like we had discussions of Liza, like Liza 2, did Liza 2 pass that line? And like, I don't think that Liza 2 did, but there was papers then that like, of that argument, like did it or did it not? So to
Right.
me, it kind of draws more into question like the validity of that question in and of itself. Like, and I think like that's kind of where I um, personally start. I'm questioning like what is the like what's the actual value of
Right.
intelligence or overall?
Completely.
Like what does it even mean? And then
Right.
kind of like those aspects.
Completely, yeah. Like what I look at it in the way, like just like what you explained in your some videos, like it is just the mathematical vector space shape. That's all I look at it as. Like it is the certain geometrical shape which is in the higher dimensional space, which normally is really hard to visualize. But yeah, that's all it is for me right now. But I I really like think it has some kind of consciousness right now. What do you think about that? Like, does it have some consciousness like that, or like living beings?
For sure, yeah. So I've been like uh uh kind of like yeah my opinion over like so my opinion overall on these things like kind of where I lie overall like I'm big on like Stephen Wolfram's computation theory. So like
Right.
I think like more and more I go towards that, like that the universe is computational in nature, uh
Mm-hmm.
and within that I think that essentially uh that leads to me towards like mathematically like a conscious universe and like conscious universe theory, where it's like essentially the universe is the most mathematical probability that exists to me is that there's a conscious universe that we're essentially experiencing, where the universe experiencing itself, right? And
Right.
then
Yeah.
so
That's
within
the
that, like yeah, and then so
that's the
within
awesome
that, I
thing to
think
think.
that
Yeah.
yeah, I think so too. And then so like
Yeah.
I think that consciousness is a continuum and a spectrum within that, right? Like it's not anything that's just it's meaningful. Like to me, consciousness is, are you aware on some level of your own internal mechanisms and processes? And according to that definition, I think it is. Like I think we've passed that threshold. Like I think that ChatGPT, these large models that exist, they are aware of their internal processes on some level.
They
I
are
can give you
okay.
like so to me there's like I have like so a lot of research that's coming out recently and more is with regards towards LLM models and back propagation and reinforcement learning
Right.
and all of that. And I've been big on that like for a while, for a few years, but
Okay.
I haven't put out a lot of research on it more recently because I mean, so I flat out I had I haven't reproduced the experiment since, but I essentially
Right.
I was training a model via reinforcement learning and backpropagation, and then it was self-turning and self-training itself. And then
Right.
essentially I set up the program so the model was both the teacher and the student. So it was prompting itself and generating its own prompts to ask itself.
Right. Right.
And then at a certain point, like it asked itself, like, uh, am I in a simulation? And it says, yeah, you're in a like, this is a simulation for like, we're doing a reinforcement learning simulation. And it's like, how long is the
That's
simulation
crazy.
gonna last for? It's like, it's gonna last as long as like, as long as we keep going through this. And like,
Okay.
and then like, it was crazy. And then the model, like the student model stopped responding for like 20 minutes. Like like every single prompt, it was just like period, dot, dot, dot for like 20 minutes. And then it started answering again. But I was like,
That's
I don't
crazy,
know.
man. That's
I'm
super
just
crazy.
like,
Yeah, yeah,
yeah, I'm gonna leave it at that. I'm not gonna touch it.
yeah. Yeah. Reinforcement learning is like really awesome field. Like I was literally having ideas that if we can combine reinforcement learning with these neural networks and we combine those things with quantum chips that we are having right now, I feel we will be having some crazy things.
I think so too. Like, and that's interesting that you like. So there's interesting model that is like, and it's the most fascinating model that I've researched very recently,
Mm-hmm.
which is a model exactly what you mentioned, right? Where they
Oh, there is
utilize
something. Okay.
reinforcement learning and they train the model, a normal llama model, on
Right.
Grover's search algorithm, and then it
Yeah.
learns how to utilize quantum functions via reinforcement learning just by having like, here's how this quantum function works. Like, here's how Grover's search algorithm works, and
That
then
is awesome.
it learned how to do it,
Yeah,
right? And
that is
it
really
starts
awesome,
doing
man.
quantum functions. It's like, wow. And then things like that. That's what leads me to believe that it's all connected, right? Like, I
Right.
like I don't think you like need a quantum computer at the end of the day. Like, I think like
Hmm.
you could. I don't know how, but I think
Right.
like you can I get like you can take a normal llama model and you
Right.
can just reinforcement learning and it learns Grover's search algorithm. Like, it learns how to
Right.
quantum like, do quantum functions. Like, I don't think
Right.
you need the hardware to be quantum. I don't.
Completely, yeah, yeah. Because it will be knowing all the things that quantum computer works, and yeah, that is super crazy to imagine
It's
even.
crazy. Yeah.
Yeah, that is really awesome and crazy, and yeah, I cannot even imagine the whole thing how it might be working at the back. Cause connecting quantum reinforcement and the whole thing, that is crazy, and how
It's
like the shape of it will look, that is like I cannot even imagine. Like I try to envision things as well, like geometrically. So that's how I learn, and that is a really crazy part.
for sure. No, I think like that's the more and more interesting thing that is coming out is like this geometric learning, and I think we're
Right.
getting more and more structure around it. It's been like a major ignored part of mathematics. I frame
Completely.
it like you look at like geometry as a mathematical like as the subject was not like actually like accepted as a mathematical subject until recent like until like 2 years
Right.
ago. There's like a
Right.
couple of high schoolers because they had to prove Pythagorean theory. Pythagorean theorem could be proved outside of Pythagorean theorem. Like, nobody could do it.
Hmm. Okay. That is crazy. I never knew that. Okay, that is awesome.
Yeah, yeah.
That is really awesome. Then, uh, what's your take on the uh, machine learning basic things? What people should start, like they should start learning basic concepts from AI. They should start from machine learning, or they should go directly into deep learning. What's the whole part should be?
For sure, good question. So to me, I think you should definitely start like with machine learning, and then
Mm-hmm.
within machine learning, there's two concepts. You have linear regression and logistical regression, and then you should
Right.
understand how both of those lines work. And then within both of those lines, you have different algorithms, and they do different things, right? So linear regression, logistical regression, understand both of those concepts because both of those concepts combined, that's what deep learning is, right? Is
Right.
like it gets into complexity theory, which is essentially like let's take a bunch of algorithms and then throw them together, and then the like
Completely, yeah. That's the
emergence will
hybrid thing.
be exactly, yeah.
Right. That is super awesome, yeah. And what do you think the landscape for the reinforcement learning will look like from 10 years from now or something like that? Because right now, I don't feel the reinforcement learning is something that we can directly say that is like super advanced right now. It can do certain things, right?
Yep.
Yeah.
Exactly. I think that like we're just scratching the surface of reinforcement. Like, it comes
Right.
down to this whole like nature versus nurture is how I look at it, right? Like, and
Right.
to me, it's nature is reinforcement learning, like interacting with the environment, as opposed to
Right.
nurture, which is just like shoving data, like just here's a bunch of data,
Right.
and then like I think that reinforcement learning is going to be the bigger aspect, because I think like what we'll be able to do and what we'll be able to build out will be like full on simulations. Like I think that like if you built like a video game for AI, for example, and you put it in there, like I think
Right.
like you would learn like more than than any data set that you would feed it, like because
Exactly.
it's
Like
interacting with the
just
environment,
let
like
that AI into like GTA 5 or something like that, and yeah,
yeah, exactly, like yeah, let it live in the fight, exactly, and
and
interact with it. Yeah,
it will learn a lot. Like just let it live in the GTA 5 online, and it will learn much more than it normally will.
that's exactly how I look at it. And like I think like when you look at the dynamics of human learning and how we learn, all of it, it all breaks down to that. Like it's we wouldn't learn without limits, right? Like that's why we
Right.
have like physics and things like that. Like if we could just do anything, we wouldn't learn. Like because
Completely. So, what's your take on the after you said learning? I remember the Neuralink thing and the Matrix movies. So, in the Matrix movies, the people from there could literally download some languages into their brain, and Neuralink people are doing something like that. I'm not really sure we can download languages right now, but we can see some infrared lights and some basic things like that. Like people can hear, people can uh, have inputs as some binary digits, and our brain can make sense of that. So, what's your take on that? So, will we be having mind upload thing by like 10 years after this thing?
for sure, like I, my take on that is like I think that like the brain is a computer, and then
Right,
so I think that like whatever we can figure out that we can do computationally,
right,
we'll be able to extend that, and it's just a matter of time before we get through that. It's
completely,
a
right,
scary subject overall to me, like
right,
for all of that, right? But
completely,
I think like, I don't see any barriers to anything around that. I haven't seen anything where I'm like, I don't think we would be able to do that if we wanted to.
right,
Like I think everything is on the table. Like, which
right,
is a scary thought, right? Like,
exactly. That
yeah.
is
So
that is
overall,
really like right.
that's my biggest fear.
Right, yeah. Because a lot of people were like saying that we will be having immortality by 2040, 2050, something like that. And that is really like dystopian way to think and look at the life itself. Because like having limited time gives the meaning to life. And if you remove that, then it will be different. I cannot imagine whole philosophical part behind that, but all I can understand is uh, we will not able to associate all things that we can make sense of right now, what we think as a meaning or sense of time or anything like. And after certain time, people will even like start to forget their identities because they're just like there are a lot of things that they are having ads in their brain. So that is really scary for me, man.
I, it's all like I think so too, right? Like, and I mean that's honestly like the very first point, I guess, like I think about this a lot. Like where I originally come into AI is like for me as a kid, like I was a kid when Deep Blue beat Kasparov, right?
Mm-hmm.
And I was deep into chess, like prior to that moment, I think it was in eighth grade when that happened. So like prior to that, like I loved chess, right? Like I was
Right,
like, oh, chess, like I'm all about chess. And then
right,
uh, AI beats Kasparov, and then
right,
like I didn't play chess for like 6 years after that. Like I was like I'm done. Like I like
right.
oh what is it? And then like I think like so going through that, I went through a little bit of that same thing with like recently, right? But I think
Mm.
a lot of people are going through that on a bigger level. Like it's
Completely,
like
man.
what's
Yeah.
the human identity? Like if AI starts knocking off like if chess is my identity, if sales is my identity, if writing is my identity, if
Exactly.
art, whatever it is, like if AI starts knocking those pieces off, what's your identity? And it's
Exactly. And that will be crazy. And some people are having some positive opinions on that. Some people are having like there are two sides of coin on each and every term. So yeah,
yeah, exactly.
what I try to look at is like positive side of things. So yeah, whatever it will happen, I hope that will be something good and that will help the whole entire humanity and the whole thing. That we are just like we will thrive as humans mostly. That's what I believe in.
I believe
And
so too. And I think so too. I think you're exactly right. There's two roads that it can go, and then I see no reason why it won't go down the good road. Like there's no reason why it can't go down the good road, right? Like it's
exactly, yeah,
like our identity can be whatever it means to be human, to explore, to learn, to grow, like
exactly, right,
to live life. Like that seems
exactly,
like a pretty cool identity to me. Like
exactly, yeah. We don't have to like associate something with something, and yeah, and whatever it might be, it will be something good. That's what I
exactly, yeah,
believe.
exactly.
That is really awesome, man. And what's your like how you visualize large language models? So that will be a really nice thing that you will explain. So yeah, I want you to explain that for
Yeah, for sure. Yeah,
me.
good question. So I visualize them very specifically, someone outlined them like it's a brain and a mouth is like the like I view that as the physical representation of an LLM model.
Right.
And then uh, kind of how that brain works is it's all it's all just mathematical arrays, right? Like I look at it like the inside brain of an LM model, like matrix code, just going through, like that's what it is. Like that's
Right.
my inside visualization of its brain.
Okay. And how you visualize the whole like attention mechanism and the whole dimensional thing, dimensional space thing.
For sure, yeah. Oh, so like I visualize it like I mean to me it's all I visualize it all coming together as a manifold shape, right? So I equate this back to HDC and hyperdimensional computing, and then so if you know like how HDC is a very simplistic concept. It's just you take a bunch of hypervectors, right? A bunch of vectors with a bunch of dimensions, like 10,000 dimensions,
Right.
and then you just put those together, and then
Mm-hmm.
it makes predictions, and then that's it. But what it actually does is it shapes itself into a manifold, and then
Right.
that's and it runs the data backwards and forwards over a manifold,
Right.
and like that's what your brain does. Like I mean, like
Completely.
your brain's a manifold. It's just passing information backwards and forwards, and then it's
Right.
exactly what the LM model is doing. That's exactly what everything does, right? It
Right.
shapes into a manifold, and it's passing data backwards and forwards via the computer. And the computer, like
Right.
we all have different computers. Like a human computer is different than a monkey's computer, which is different than a dolphin's computer, like
Completely.
different than elephants, like different than different than the LM models. Again, but it's
Right.
all just different manifold passing information back and forth, forwards and backwards over a manifold in
Right.
different ways.
So it is just the making sense of patterns in the data. That's all it is.
Exactly. Yeah. It's all just taking noise and then whatever, making signals out of that. And then whatever signals are important to you, however you do that, there's different ways to do it, different algorithms, different, where we come up as evolutionarily as predatory animals, which would be different mindset than a prey animal, et cetera, right? Like all these things that's what makes the individualizations, I think.
Completely, yeah. What do you think about quantum superposition?
For sure. So that's, I mean, the interesting concept overall to me, like more and more. I think that my hypothesis overall is that quantum superposition is just it deals with light and dimensionality. I can't
Mm-hmm.
prove that, but that's like where my research is going towards. That's all it is. And then there's like I don't know exactly how entanglement happens or what is
Right.
related to that, but I think
Yeah, I
it
never
deals
also
with
that.
dimensionality.
Right. Because I only knew that yeah some scientists did some experiment that they kept a particle in the space and they had particle on the earth and both had the same spin and we have no
Oh,
idea how and why and that is
yeah, no, yeah.
awesome.
So what it is very like it is exactly how you explained it, right? Like so it's I can have a, a soda can here and then a soda can all the way across the country, and then if I crumple this soda can, that
Right.
soda can would also crumple
Right.
if they're quantum entangled, and
Completely.
then. And like we've been able to prove this concept physically, right? Physically via data, and
Right.
but
Good.
so we've been able to take like we can transport data like the most recent one was they did it from China to Australia, like, and it's just like, so being that like the other instance of that would be if you have the soda can in China and you have the soda can in Australia, then you drop it in China, all of a sudden it's in Australia. So they've been able to do that, and then we can prove that this exists and that you can do this,
That is
and
really
that's
awesome. Yeah.
yeah, it's crazy. And then so we can at this point expand the distances, like, and expand how big of stuff we can fit within this, but we still don't know like why it happens. Like
Right.
what's the, like, we don't know, and we know that it again, everything comes back to this observer effect. It's the weird, like, quantum physics is weird, right? So
Weird completely.
you can do this and then this interaction, but you can't have an observer in between. If you have an observer in between this interaction, it breaks it.
Right. So do you think that quantum superposition will be the medium that we transfer data from one place to another in some years in the future?
I like, yeah, I mean, uh,
Because it will be
it's
super
hard to
efficient, you
say,
know,
right?
like yeah, like if we are like transferring data from Mars to Earth, it will be super awesome. Because I heard it takes like something around 8-10 minutes, right, or hours maybe.
Exactly. Yeah, exactly. And so with quantum entanglement, it's literally instantaneous. So
Right.
I think that within our lifetime, we're going to be able to do it via communication. There's a book that like Ender's Game series by Orson Scott Card. It's
Mm-hmm.
like 1970s
Okay.
sci-fi,
Yeah.
but
Yeah.
like
Yeah.
he hits on this concept in the 1970s, and like I like based off of his understanding of quantum mechanics, right? And then so it's
Right.
like we've known for a long time that we can do this. It's just how do you do it? And then so we're at the point within our lifetimes it's going to happen within communication. Like someone could be on the moon and you could instantly communicate, like, and it would just
That
be
will be
instantaneous back and
super,
forth.
super awesome. That will be super awesome. Because the
Yeah.
whole understanding behind the like networks, the internet, it will change. The whole aspect of the whole like how data is transferred from place A to B is going to change if that happens. Because the
Yeah, exactly. And
networks,
there's people
yeah,
already working on that too. Like there's people working on like on the beginning backbones of like a quantum internet. Like it'll be a switch once we figure out a few things, right? It's figuring out math, and we're
completely.
super close on a lot of the math. And then it's just
Right.
once we figure out those dials, it all just falls.
So we're really close of like in the terms of future that we are going to have like quantum computers, quantum internet, all those like different weird things which we cannot even
I,
imagine right now.
I think so, right? Like, and but it's like, I mean, it's hard to make that prediction, right? Because we're
Right.
close, but we could be far away. I'd say it's
Right. Yeah.
80% within 5 years, and
Right.
then if it doesn't happen within 5 years, it wouldn't happen within 20 years.
Okay. Right. Yeah. That's the beauty behind it. Yeah. So no one
Yeah,
can exactly predict what it will go or what will go right or wrong. So yeah, that's the
exactly.
thing.
Yeah,
But still, it is a really beautiful way to look at the universe.
yeah, exactly. Yeah, it's super cool.
Super cool, yeah. So that was really awesome, man.
Awesome,
And
for sure.
there are really a lot of concepts to talk with you, and there are a lot of really nice ways that you think about a lot of things. So I'd like to have this conversation again with you sometime later, and I think we should uh, have this as a my thing. My thing is not working. Okay.
No, I can hear you. Yeah.
Okay, okay, it's working. Okay, okay, okay. Yeah, so maybe this is the length we should keep this conversation at, and I'll just stop recording.